All right, so happy return. This is the sinusoidal functions test. So basically, if you're in grade 11 and, so sinusoidal, so just sines or cosines that you have started to deal with and learning about periodic functions, here's a little test for you to try to see if you can do it. So as usual for the tests that I post, I will provide a link so you can download it, okay, in the show notes, try it out, come back, and then see the solutions. Okay, let's get started. Okay, so question number 1, it says from the given graphs, find the period, amplitude, and mid-range. So in this question, I give you 3 graphs, A, B, and I guess C. And really just want to go over kind of the basics with regards to, periodic functions, and then making sure that you can capture the period, capture the amplitude, and then capture the mid-range of that periodic function if it exists. So this first example, so this one that you see here, okay, so right away visually I can see that it is actually not periodic. So it looks like it's, most likely blowing up here. We don't know what's happening beyond that point, but it's kind of blowing up within there. It is not periodic, so there isn't like a cycle where I can take out and that cycle continuously just repeats over time. It probably looks like some kind of a polynomial function, to be honest with you. So that's what I kind of see. You do have some kind of a minimum here, right there. There's a switch over, from here to here. So you have crossings through the 0, but it's not periodic. So it's not going to really have a period. It doesn't have an amplitude, and it doesn't have any mid-range either, because it looks like it kind of blows up to the top. So nothing to do with this one. You can say this one is non-periodic. So that's all I'm going to say right here. Now for the second one right here, so it looks like it's kind of like a zigzag going back and forth. So this one does look periodic to me. Now the cycle that you choose, I guess that's up to you. So remember, one cycle is basically the process that you go through where you can see that particular cycle then just keeps repeating. Now it has like almost like a zigzag going back up. So there's a black one, there's a blue one, and then there's a red one. So we can take one of those. So for instance, I'll make it easier for myself. I'll take the middle one right here. So if I can go from here and then to here, then it looks like it is repeating. So first off, so my period, so I guess it would have been basically from here to here. So it's from -2 to 2. And that means that it would have been 4. Now, we don't know exactly what this, what x, okay, so, or what the independent variable is, and we don't know the unit, but we can say that the period, I'm going to designate the period with a capital T, okay, is equal to 4. Whatever, 4 units of something. Okay, so that's from 2 to -2, and then it just repeats over and over. So this is just its cycle. Its mid-range, so that would have been the middle point. So it looks like it's going from 1 to 5. So if you take that, so and in the middle, so I guess, we would have been going, so our mid-range point would have been right there, right? So it's 5 minus 1, which is 4. Okay, so 2, which is going to give us also the amplitude. So that's going to be the height right here. So I can see that this particular height has an amplitude of 2. So I can say, amplitude is equal to 2. Whatever, mid-range, okay, is 3. Okay, so that equation, so y is equal to 3, is going to give you that mid-range point. So that's what we have for B. And for C, this one looks kind of periodic, right? So because, it's kind of repeating a pattern of a wave. But the problem here is this wave just keeps growing, right? So notice that it just keeps growing out in this kind of direction. It's like this cone right here that we have, and it just keeps getting bigger and bigger. So we actually don't have a period. It's not a periodic function because we would need a cycle, and that cycle would have to continuously repeat over and over. but nothing's repeating. I mean, it looks like it's waving up and down, but it's just getting bigger and bigger and bigger and bigger as it continues on. So this is also non-periodic. All right, so those are the first kind of 3 examples with respect to question 1. Okay, let's take a look at question 2. It says, sketch the following functions and find, again, the period, mid-range, amplitude, in this case, maximum, minimum values, and then I guess put the domain and range. Okay. All right, so for this question, let's try to sketch it out. I'm going to first kind of readjust this just so that I can kind of write it out in those transformations. So -2 sine, I'll clean up the inside there. Okay, let's kind of swap it so it looks like, the format that we want, which is, we have some so some d, x minus, h, kind of like that. So let's shift this over. So I'm going to move the negative. So I'll take the negative out. I'll take the x. Well, that's going to make this negative pi over 4 and then -1. Okay, so now we know exactly kind of what to do, and I'll walk through these one by one. Before I do that, let me just sketch one sine wave, so one cycle of that sine, and then we're going to work with that one sine wave and, do the transformation to it and then fill out the rest, because it's within here there's no restrictions, so it's kind of infinite number of cycles. Okay, so give me a moment. Okay, so here it is. So here's our sine, and now we're going to be manipulating it. So first of all, if I work with this, so we know that this increases the amplitude, so it's going to stretch out the amplitude, make the amplitude 2. It's going to pull it apart. But it's also going to reflect in the x because of the fact that you have that negative. So maybe what I'll do is I'll do that kind of in one go. And so what would that be? So it's going to kind of look like this. So here's your reflection and then the stretch out. Okay, so it's going to go like that. All right, so that's this, -2. Okay, so if you would sketch that out. Now the second one, so this negative, so we know that that's, the compression and stretch, but it's -1. So it doesn't change our period. And then so, remember that your period is 2 pi. Now in this case, it's going to be, so it's -1 in there. So that means it doesn't really change our period. So our period stays the same, but we do have a reflection because of the negative. So this is going to look kind of weird, but it's going to gets reflected back like this. Okay, this gets reflected in the y. Now it also gets shifted over, so by pi over 4, so it's going to go in this direction by pi over 4. So I guess it's gonna get shifted this way, right? Pi over 4, because that would have been that. Let me see if I can. There we go. Okay, so it kind of looks like this. So that's just the translation, the shift, and then it's going to go down, and it's going to go down by 1. So I'm going to do the same thing. So I'll kind of shift it over by 1. So it goes down by 1, and this goes down by 1. So it kind of looks like that. Okay. And so from here, afterwards, I mean, all we're going to do is, if I copy this, I mean, you can, let me see if I can just duplicate this. There we go. Okay, so it's kind of going to look like this. And, this would continue on. So it would go this direction, and it would go on in this direction. So those cycles keep repeating. Let me remove this, and let me remove that. Okay, so it's kind of going to look more or less like this. Now, from that we can obtain, so we already know. So we know our period, so we said period doesn't change, it's 2 pi. We know our amplitude, so our amplitude is right here, so that's 2. It's easy to tell from these sines or cosines. So amplitude is 2, period is 2 pi. Our mid Well, it goes, so our maximum is 1, so it goes, that's the maximum point. The minimum point is -3. So, if you go in between there, so I guess your, right here would have been your mid-range, okay, which is -1. That's the mid of that. And then our domain, well, our domain is not restricted, so it's basically x is just all real numbers, and we're assuming that it's in radians. So x is not restricted. The y, the range, well, the range is restricted, and I guess you can write that out. So for the range, okay, so it's going to be restricted between, so -3 and 1, right? Because it doesn't go up higher or lower than that. And that's it. So that's that particular question. We can try to graph it as well. You can take decimals and graph it out to see. I'll avoid it for this one. If you want to use decimals, you can, just to check your answers if you want. But that's how you would do these. Okay, let's take a look at that part B. They gave us another one. So here it is. This one is in degrees, okay? So this is not going to really change anything for us. Let me paste it in here. Okay, so that's part B. So again, we're going to just kind of pick off, well, so first let me rewrite it, 1.5 cos. I always like to just rewrite this x. It's going to be plus, you took out 2, so that's 90 plus 0.5. Okay. So we can do that. All right, so here you go. So here's your cos function, okay? And so it goes in the negative direction there as well. I put it in degrees. And so now we can kind of, complete the whole thing. So this is 1.5. Well, the only thing that will do is it's going to stretch this out, okay, like this. All right, so it's going to look like that. It's going to be a stretch out, 1.5. There's no reflection. It's positive. Our period, so notice our period here. So that's going to be, so our period is 360 divided by that. Okay, so it compresses the period down. Okay, so it's going to be 180. So that means we're going to kind of get shifted in here. So now, and it's negative, so it also gets reflected back. So, do it one at a time. Okay, it's going to be a little tricky here, I guess. Okay, so really what you're doing is you're going to be, every point here, you can kind of take points along and then shift them out, right? Okay, so these are, whoops, what am I doing here? So here, these are the points I'm going to try to move over. So we know the middle, the first point. So this point, right, because our period now is 180, so this is going to get shifted all the way here. Okay, so that gets compressed in that direction. This 270 that we have, okay, also gets compressed, okay, and then this 180 gets compressed to 90, I guess. Okay, so what we have there, so it's going to look a little funny here, but it's going to look kind of like this, all right, and gets kind of like that. So it gets compressed in, and it does get reflected back. Okay, so it's in the it's in the y direction. Okay, so it's going to get shifted over and swung in that direction there. So this is going to be, I guess this is 90, this is 180. So it's going to look kind of like this. It's going to go in here. Oops, that's not, it's a little bit off. Okay, so it's going to go, oh, this is getting tricky. Okay, kind of like that. Okay, so those points get reflected back. Okay, right there. It's not perfect, but I think you know what I mean. So it gets reflected. Now, plus 90, so that means it's going to go negative 90 in this direction. Okay, so this thing is going to now get shifted over. And let's see if I shift this over. Okay, like this. Okay, whoops, that's not what we wanted. Okay, so it gets shifted over by 90. Working the way I want it. Okay, there we go. So that's this shift over to the left. And then up by 0.5. All right, so it's going to go up by 0.5. So I guess this gets, well, everything gets here shifted by up by 0.5. Go, and there we go. Okay, so there we have it. So it moved up by 0.5, and now it just keeps repeating. So what I'm going to do is I'm going to actually kind of draw over this so that I create just one of them. Okay, so like that, and now I can take this and duplicate and repeat. Okay, and duplicate. That's not what I wanted. Okay, and repeat. Okay, so it just kind of gets shifted over. Okay, like that. That's a mess, right? You can delete all of these. You know, you're sketching it out, but it kind of looks like this. All right. I'm gonna actually chuck this one on Desmos so that you can see, you know, so that it goes in between. Now to identify, so your amplitude is 1.5. Your period here, it's going to be 180 degrees. Your mid-range, which is the kind of midpoint, so it's between 1 and 2 there. Notice, okay, sorry, between -1 and 2. So that means it's going to be 0.5, right? Okay, so your mid-range is 0.5. So that's that. Your maximum minimum values, so that's 2 and -1. Okay, so that's what we have there. Our domain, well, we have no restrictions, so our domain is open. So it's all degrees, okay, so all real numbers that are degrees. That's for domain. And then range is between -1 and 2. Okay, so you can write that in if you like. Okay, let me pop up Desmos just to see it. Okay, so here's Desmos. Now, one thing actually that I didn't point out, but I'll point out here for you, because it's in degrees, you can actually change in Desmos. So if you go and hit, you know, the on the top right corner there, okay, it's the range, which is the settings. You can actually change it back to degrees. All right. So now, if you change it back to degrees, obviously this is you're gonna have to kind of zoom in here. There we have it. Okay. So this is what it would have been like. Okay. So now let's see. I'm gonna try to bring out what we kind of drew out. Let's see how close we are. Okay, I mean, obviously mine isn't, you know, the greatest there, but you know, these points that we have here, so minus, okay, so this is minus 90, and that's what we have there. The top there is 2, and then it goes through -1, right? And then it goes through 90, and it's at 2, so you can see that they're related. Obviously mine isn't as pretty as this one, okay, but this is what it was. And in the settings, you can change it back to degrees, okay, for your independent variable if you like, which is super useful. All right. Okay, so that's another question for us. So let's now continue. Okay, so we'll take a look. Okay, so what else do they give us? So question 3. I'm gonna take this. Okay, let's copy it down. That's question number 3. This one doesn't look very long. Take the following function, x is in degrees with domain all real numbers, and write its sign equivalent. Okay. So notice this is cos. Okay, so what they're asking us to do is basically, what is the equivalent of this if you wrote it out as a sine? And, you know, if you've watched over the lectures, okay, the lecture series on these, then you know that that's actually not that very hard to do. So remember, when you have sine of x, this is the same thing as taking cos of x. Now this is in degrees. So, and all you're doing is you're just translating it by 90 degrees. But if it's in cos of x, okay, and you want to write it as sine of x, okay, then you're going to be translating it the opposite direction. So if we take this whole thing, let me rewrite it. So it's h of x is equals to negative 10 cos negative 2x plus 270 minus 8. So I'm just going to show you what you do. Okay, so you'll take this, let's duplicate it. It's going to be identical. Okay, it's going to be identical. Instead of cos, all you do is you say sine, and now in the brackets you have to shift it, okay, by plus 90. You have to say plus, well, 90 if it's in degrees, or pi over 2. And that's it. So that's what you do. So now if you rewrite this, now obviously you can say negative sine, sorry, negative 10 sine, negative 2x, now plus 90. So that's going to be plus, and 270 plus 90, which is going to be, why am I blanking? 90, so this is just 360 minus 8. And if you want, you know, to be really keen, you can set it up so that it looks exactly, it's going to be minus 180 in terms of those transformations, right? So that's how it would look like in this case. And that's all that you have. And what I'm going to do is I'm going to plot both of these up, and you will see that they're going to be on top of each other. Okay, so let me just pop out decimals, and I'm going to write both of them in. I'll keep it in degrees there. Okay, so here it is. Okay, I just plotted them back on, and I just want to show you. Okay, so they're identical, and then all you do is here, so you're going to say plus 90, and it is the same thing, right? You can simplify if you want, but that's all that it would be. Okay, so that's pretty much it. Okay, so for that one. Okay, so that's another question out of the way. Let's take a look. Let's keep going. Let's see what else they give us. Is anything more difficult? I'm going to go back. So that was question 3. And question 4, write the equation of the function that represents the given graph, include domain and range. Write the first graph using sine and the second as cos. Assume first graph is in radians and the second is in degrees. Okay, so here are, okay, so this is the last one. So let's break it down. I'm going to copy this. So here's the first one. I'm supposed to write this as sine. Okay, and it's in radians. Okay, so let's pluck it here. And let's see how well you remember this. So we're supposed to create a function out of this. So because we are working with sine, you know, so what you want is you want to be able to take one cycle, right? So we're going to try to find one cycle here. And so that's the first thing that we'll do. Now, in order to find that one cycle, notice it goes from negative 1, sorry, from 1 up top there, to negative 5 right here. Okay, so in between there, so what we have, okay, that means our mid-range is going to be basically right here. So this is our mid-range. Okay, so this is what we have. Now, our mid-range means that that's what it got shifted, well, in this case, it got shifted down by negative 2. And our goal is going to be to try to write this entire thing out. Okay? All right, so, what do we have? Okay, I'm going to try to find just one of them. Let's try to find a convenient one in here. So it looks like it's starting, right? It's starting somewhere a little bit further than 1. So we are going to do a little bit of guessing. Okay. So it looks like it's starting from 1 and it's ending somewhere around here. Okay. Something like that. And now 1 cycle. Okay, I'm going to pick convenient one. So let's take this one. I'm going to take this. It's going to be 1 sine. Okay, that's what I'm going to be my starting point. That's what I'm going to concentrate. And then from here, I'm going to try to find everything that I need. Okay, so first of all, amplitude. Okay, so my amplitude right here is 3, right? From negative 2 going up to 1. So my function is going to be 3 sine, okay? Now, okay, so what has happened to my period? This is in radians. Okay, so that means if it's from here to here, I mean, it's pi. I'm going to assume that it's pi. So it's just, what is this? Okay, so trying to find, so this is, I'm trying to find, whatever value this is right here. So somewhere along here, and then somewhere along here. Okay. So pi over 2, I think it's pi over 2, right? Because pi over 2 is 1.57. And that's between 1. So this looks like it's pi over 2. And then this one is just, is this 3 pi over 2? Let's see. So 3 pi over 2. No, because it's under that. So maybe it's pi. Yeah, so this one's a little tricky. Okay, so it's less than 4, between 4 and 3. Maybe it's 7 pi over 6. Yeah, okay, there we go. 3.6, yeah. So it's 7 pi over 6. Ooh, that was mean. Okay, so 7 pi over 6. So that means the period, so 7 pi over 6 minus pi over 2, right? So that's going to be the period of this thing, period. So that's 7 pi over 6, and let's put this is 3 pi over 6, which is going to be, I guess, 4 pi over 6, which is 2 pi over 3. So that's the period. So 2 pi over 3, which is equal to 2 pi all over, right? Whatever we need to put in here. That's your D. Okay, so that means it's 3. Okay, so this is going to be 3. That was mean. Okay, so that's 3. Now, right, so we've compressed it in by 3. Now the translations. So, well, the starting point is pi over 2. So that means this got shifted over x minus pi over 2. Okay, so it got shifted over here. That's the pi over 2. And then it went down minus 2. And there we have it. All right. So that would have been our equation. Super mean. This one was not easy for sure. Okay, so that's how we can kind of proceed and then find out the details to go out. Now, let's see, did they ask us anything else? Assume that the graph, radiance, and the, okay, domain and ranges. Okay, so well, the domain, I guess, what did we start with? The domain, so that went from here to here. The range is easy. The range is between 1 and -5, right at the bottom. So those ones you can write right there. This one, again, it's going to be a little annoying because this is a little bit over 1. Pi over 3. Should have known that. Okay, so it's pi over 3, which I guess, my gosh, all that work? Yeah, because it's a little bit over, right? So that's pi over 3. So that's your domain. So it starts at pi over 3. And then it goes all the way. Now, how many cycles is that? 1, 2, 3, 4 cycles. So 4 cycles. So 4 times the period, right? From your starting point, which was pi over 3. So 4 times the period. So that's what it's going to be. This is brutal. So if radians, sometimes working these things out is a little bit annoying. So this is 8 pi over 3, 1, which is 9 pi over 3, which is 3 pi, which is 3 pi. Okay, so that's 3 pi. So that means your domain, whoa, x, so it's going to be between, and we said that was pi over 3. Holy moly. Okay, so there you go. That was a really mean one. I mean, you probably maybe have seen it and you were capable of doing it a little bit faster than I am, but because they wanted that domain, I just wanted to go through that. And most of the time when they plot this for you, they'll probably plot it using pi, so it's so much easier. But because here it's kind of sketched out and I don't really see, so I'm guessing. You know, I'm trying to figure out what those things are, but there you have it. So that's your domain for this particular example. All right, so let's do the last one. All right, so here's the last one, and they said to do it in cos. So we'll do it in cos. Now it's in degrees, so this one should be a little bit easier to tell. Now with cos, so again, I'm gonna just identify one cycle of the cos. So it's gonna be from here to here. Okay, domain, oh thank goodness. Okay, so this one's from 0, 700, let's see what these are. This ends at 1 there, 1, 2, 3, 4, that's 5, so that's 720. Okay, so that's the domain. Whew. Okay, so this one is much nicer for the domain. So it's between 0 and 720. That's your domain. Our range is from 2.5 to negative 0.5, so you can write that in. So that means this is my midpoint range, right? That's midpoint right there. So that's going to be, here's your amplitude then, which is going to be 1.5 in amplitude for your cos. So whatever, g of x, let's write. So it's 1.5 cos. We brought it up by 1 plus 1. And now we did shift it over as well. So notice it starts from there. So that's what, 90 degrees. So it's shifted over to this way, 90. So this is going to be, so x minus 90. So we're just looking for this. Okay, so how much has it compressed? So it went from 90 to 70. It's 270. Okay, so it's 270 minus 90, which is 180. Okay. So that means it compressed it by 2. All right, so if that's your period, which is 180, so that means your overall period, right, which is going to be, this is your D. So this D has to be equal to 2, because that's going to give you the 180 for your period. And that's your, there you go. So this one was much, much faster. And you have the domain there. You can plot it on decimals if you like. Okay, this took a little bit out of me. All right, okay, so it's definitely a wicked test. Okay, it should challenge you a bit. And you definitely should be comfortable with all of these transformations and understanding these sines and cosines by completing this test. Okay, thanks for watching. See you in a future video. Bye, everybody.